More on quadratic functions. A review of what we've talked about so far. In quadratic functions, your standard form is a function of the form ax squared plus bx plus c, where a, b, and c are real numbers. A cannot be equal to 0. These graphs will always graph what we call a parabola, that U shape. A parabola that opens a function, quadratic function or parabola that opens upward, has a minimum value at the vertex, has a vertical axis of symmetry. A parabola that opens downward has a maximum value at the vertex, has a vertical axis of symmetry as well. The mother curve that we use, the basic curve y equals x squared, this is again the graph of that to kind of give you an idea of how all of them are based. Here's a couple of graphs of quadratic functions or parabolas. And if you'll notice, sometimes when you graph a parabola, they will actually, you'll have points where you cross the x-axis. Points of a graph that cross the x-axis are also called x-intercepts, also called roots, and called zeros of a function. Now, these points are where the y value are equal to 0. So if you set your quadratic function equal to 0 and solve it, you can find the points where you cross the x-intercept, or the x-axis. The points where the y is equal to 0. So you could use quadratic formula possibly, or you could use factoring or some property to solve and set those equal to 0 and solve that equation. This is an example of a parabola that would not have any x-intercepts. Notice it's never going to cross the x-axis. So it has no roots, no zeros. Y-intercepts occur where your curve crosses the y-axis. That's where x is allowed to be 0. This formula is called the vertex formula, and it's a really neat trick, little tool to use. The parabola associated with the function f of x equals ax squared plus bx plus c has a vertex at negative b over 2a. This is an awesome formula for you guys to use and memorize in this course. The x coordinate comes from the formula, the opposite of b over 2a. The y value for the vertex comes from plugging this value back into the original function. Now, some textbooks actually have a formula for the y, but I think that's harder to memorize. So I'm just like, whatever we get when we do negative b over 2a, we're going to substitute that back into the original function to find the y value. If the value of a is positive, the parabola opens upward. If it's negative, we know the parabola opens downward. To find the x-intercepts of a parabola, we're going to set the equation equal to 0. Set the function equal to 0, and to solve it by either factoring, quadratic formula, or completing the square. Probably quadratic formula and factoring are going to be your best bets when trying to solve for your x-intercepts. When you graph a quadratic function, these are some things or some steps you should go through to help you get your graph down the best you can. The first thing, determine whether the graph opens up or down. If a is greater than 0, the parabola will open upward. If it's a negative number or less than 0, it opens downward. Find the vertex. You can either find the vertex by using the vertex formula, negative b over 2a, or you could complete the square and get it in a shifted form. That might help you find the vertex like we did in previous lessons. Find any intercepts. To find the x-intercepts, if any, solve by setting the function equal to 0. If you want to find the y-intercept, you find f of 0. You plug 0 in for the x values. Then complete the graph by plotting points that you found and finding the additional points using a table of values like a t-chart. Use symmetry about the axis of symmetry to help you finish plotting it out. Let's try a problem like this. This one is in the quadratic form, and I could use completing the square like I've done in previous lessons, but I just want to show you how the formula for the vertex works. The vertex formula we said was negative b over 2a, comma, f of negative b over 2a. So in this problem, A is 1, B is negative 8, C is 15. So the opposite of B would give me positive 8 over 2 times 1. So that's 8 over 2, which we know is 4. So the vertex we know is the point 4 comma something. How do I find the y coordinate for the vertex? We plug 4 back into the original equation. So let's try that. 4 squared would be 16 minus 8 times 4 plus 15. So that's 16 minus 32 plus 15. That's negative 16 plus 15, which is negative 1. So negative 4, negative 1 is going to be the vertex for my parabola. It also asks me to find any x-intercepts. So let's see if we can do that. If I set the function equal to 0, x squared minus 8x plus 15, if I set that equal to 0, I might could factor or use the quadratic formula. I believe this one will factor. Two numbers that multiply to give me 15, but add give me negative 8, x minus 5, and x minus 3. So if you set those factors equal to 0, we get x equal to 5 and x equal to 3. That means that our parabola will actually cross the x-axis at positive 5 and negative 3. So let's use this information to help us graph this parabola. We found that our vertex on this problem was the point 4, negative 1, and that we had x-intercepts at 3, and at 5. So 4, negative 1, there's my vertex. There's an x-intercept at 3. There's an x-intercept at 5. So is that enough to graph this equation? It actually is. Now, if you want to find your y-intercept, if you let x be 0, 0, 0 plus 15, it's going to cross the y-axis up here, way up here at 15. This is good enough to know how this quadratic function is graphed. You could pick any other points on there if you wanted to make it look better, but this is really good the way we've got it right here. The vertex formula is very handy formula to use. Here's another one. Let's use the vertex formula again, and then also try to find any x-intercepts if we possibly can. So in this problem, negative b over 2a, that'd be negative 9 over 2. A is negative 1 in this problem. So negative 9 over negative 2, which we just know is 9 halves. That's actually like 4.5. So my vertex is going to be the point 9 halves, comma, something. We don't know what the y-coordinate is going to be, but I could use some arithmetic here to figure that out. We're going to put negative 9 halves back into the original problem to find the y value. So negative x squared would be 81 over 4, square the top, square the bottom, plus 9 times 9 over 2 would be 81 over 2, minus 21. Now, I'm just going to use a calculator to add that all up. 81 over 4, negative, plus 81 over 2, minus 21, and I got negative 3/4. So the vertex is the point 9 halves and negative 3/4. We can definitely plot that out. Let us see if we can find any x-intercepts on this equation. So I've got negative x squared. Let me change color so we can keep this straight. Negative x squared plus 9x minus 21 equal to 0. First thing, I don't like to solve quadratic equations that have a negative leading coefficient. So I'm just going to change all those signs. Do we know two numbers that would multiply to make 21, but add to make negative 9? Actually, no. So let's use the quadratic formula and see what we get. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Now, I don't have to really work this out because I can tell really quickly that underneath the radical, I'm going to have a negative number. 81 minus 84. So it's going to give me a negative under the radical, which is an imaginary number. So if it's complex, we know we have no x-intercepts. There's no x-intercepts in this problem, so we cannot use that to help us graph. So just by looking at our equation, we know a couple of things. We know that we found the vertex. We know it's going to open downward. And we know it's never going to cross the x-axis. So let's see what this would look like on the graph. We were given that the vertex is the point 9/2, negative 3/4. So let's try to plot that. 9/2 we said was like 4.5. So 4.5 down 3/4 means we're going to be almost down to negative 1. So somewhere around right there would be your vertex. Now, since we don't have any x-intercepts, we can't use that concept. We know it's opening downward. Also, the y-intercept would be 0 plus 0 minus 21. Negative 21. It's not going to cross the y-axis till way on down further at negative 21. So I'm going to use a t-chart to help me get the other points on the graph. Since my vertex is at 4.5 on the x-axis, I'm going to pick a couple of points to the right or to the left of 4.5 to make a t-chart. So I'm going to use 5 and 6 and see what we get. If I plug in the 5, that gives me negative 25 plus 9 times 5 is 45 minus 21, I get negative 1. So 5, negative 1, if we plot that point, we also know that 4 would also be negative 1 because of symmetry. Remember, there's always a vertical line of symmetry that runs straight through the vertex of the parabola. Now let's try 6. If I plug in 6 into this, I get negative 36 plus 9 times 6 is 54 minus 21, I got 7. So the point 6, 7. Wait a minute. Something's wrong there. Let me try the 6 again. 36 negative plus 54 minus 21. Got negative 3. I did something wrong with my calculator, so that should be negative 3. Sorry about that. So 6 negative 3, which means 3 negative 3 as well. So that's enough